Hello there. A little video here on a very specific question where you need to find the run for a ramp when you are given the rise of the ramp. So in other words, how much the ramp raises up off the ground, and you know the required slope. So this is something that's in building codes and such, that you can't have a ramp that is too steep, otherwise it would be unsafe. So here's the question. The rules for wheelchair ramps require a maximum 1-inch rise for a 1-foot run, and then our little reminder there that 1 foot is just 12 inches. How long must the run be in inches of the ramp to accommodate a 20-inch rise to the door? So the door is 20 inches above the ground. We want to build a ramp that gets up to that door, and we want to make sure that it's not too steep. So we're talking about slope here, and slope is equal to rise over run, we know. And in this particular case, they actually give us the rise and the run in a bit of an unusual way, this 1 inch to 1 foot. They actually tell us it's 12 inches. Let's just pretend they didn't, just so we know what we would do. So rise over run is apparently 1 inch over 1 foot, but that's not all that useful because those units don't match, right? So here's where we remember that. Oh, sorry, yeah, so we're gonna use this relationship we created here. So we got the slope is equal to rise over run. In this case, it's 1 inch over 1 foot. We're just gonna knock that slope right out of that equation and just use this relationship here to help answer this question. So yeah, 1 foot, we need those units to be the same on the top and the bottom there. Otherwise, that's not really a helpful fraction. So 1 foot becomes 12 inches. So we have the rise over the run is 1 inch over 12 inches. And what that means is essentially that the rise over run is just a 12th. It might be inches. For every inch up the ramp goes, it has to have a run of 12 inches, or it could be centimeters. For every 1 centimeter it goes up, it has to go over 12 centimeters. For every foot it goes up, it has to go over 12 feet. For every mile it goes up, it has to go over 12 miles. Now, that would be a very, very long ramp, but I guess we could imagine that. So we got the rise over the run is equal to 1/12. In general, right? And that's not this specific ramp, right? This specific ramp doesn't go up 1 inch and over 12 inches. This specific ramp has a rise of 20. So that rise there that we just made red, let's replace it with a 20, because that's what it is in this particular case. And now we have created just a nice little pair of fractions equal to each other. This is the ideal setup to cross multiply if you want. You can also just do it with standard equation solving, multiply both sides by 12, multiply both sides by the run, which is actually what cross multiplying is doing. Since I'm talking, let's just take a very quick detour on cross multiplying and when you cannot use it, because I see students use it all the time incorrectly. They see it once and they're like, oh, okay. And if this was not an equal sign, you could not cross multiply. Cross multiplying is very specifically when you have a fraction on the left side of an equation and a fraction on the right side and nothing else. Then you can use cross multiplication. If this was a multiplication sign here, if it was 20 over run times 1/12, cross multiplication would be meaningless. If it was addition, subtraction, division, anything else, if there was something else added or subtracted over here on either side, cross multiplication would not apply. So very specifically, one fraction on the left equal to a fraction on the right. And you will remember that you can just take the top of one and the bottom of the other. So we can go run times 1 and put it on one side of the equation. And then the other pair, 20 and 12, goes on the other side of the equation. Now, again, if you look at what we just did there, we really just cleared the fractions. If you've done the unit on clearing fractions in an equation, we multiplied both sides by run, which left us with 1 times run on one side, and we multiplied both sides by 12, so we canceled out the bottoms. But the cross multiplying is a handy little tool to pull out when it applies. So let's take a look at this. This actually works out pretty simply from here on in. The left-hand side is just run times 1. Well, that's nice. That's just going to be run, right? Run times 1. Notice again how I line up these equal signs. I know I always harp on that. And you also noticed how I started with the equal sign, then I work out the left and work out the right. That helps you wrap your mind around what it is you're doing. 12 times 20 on the right side, 240. And there we go. Our input of 20 was in inches, so our answer here is also going to be in inches. The run of the ramp must be 240 inches for this particular ramp up to the doorway to meet the required safety protocols.